back to another episode of Mo's Garage. Today in the garage we're looking at practicing on how to build an aluminum aircraft. I have no experience working on airplanes. I have no experience doing sheet metal work. The company I'm buying the aircraft kit from, which is Van's RV, supply a project test kit that allows you to hopefully gain some skills ahead of time before you start practicing on what's going to be a somewhat expensive airplane. So what's really cool is actually give you two separate little projects. A very simplistic project where you basically put a couple of pieces of sheet metal together on a aluminum angle iron, drill some holes, you rivet it, and get some kind of skill buildings in the riveting and drilling holes department. And then there's another second project that basically is kind of building a fake airfoil. So, we have these cutouts already to put together, some kind of a spar and some other bits and pieces. So you get pretty much hopefully exposed to a lot of the sheet metal type work that's going to be involved in putting the airplane together. So I thought it might be interesting just to kind of show these two kits going together. So you two can enjoy the journey and learning what it takes to build an aluminum aircraft from a kit. So basically a big giant erector set / RC airplane kit. So I'm actually excited. I'm looking forward to it. And so right now, let's kind of see what we have here and what came with the kit. Okay. So a few items before we get started. I actually spent a little bit of time on YouTube looking at different methodologies for doing this kind of work. Kit Airplanes has some really excellent video tutorials on how to do this on YouTube. One thing I noticed that they suggested was, first of all, having a sacrificial piece of wood you can drill into. And second of all, I noticed that every single thing that the gentleman on YouTube was working on had a cardboard piece on it. I suspect that this cardboard is to hopefully prevent some of the aluminum burrs from doing a number on the actual finish of the aluminum. So I'm gonna kind of follow suit, just check it out. So first things first, we've got to take this protective coating off. So I know when building the airplane, there's a couple of thoughts of school on this. One of them is to leave it on till the last possible moment so you don't scratch up your really nice aluminum surface. The other is that if you leave the stuff on for too long, it becomes just a real bear to remove. So it looks like when there's a fair amount of time spent when you're putting the airplane together, just taking this blue tape off. The first step in completing this project is to go ahead and mark out the locations of where we're going to drill the holes. The plan sheet kind of gives you the dimensions and the locations. It also gives you the hole sizes to be drilled. So I'm going to start off by doing that. So the next step is going to be to do a center punch on all these locations so we can drill them out. Now, I have never used these automatic center punches before. I've always just used a hammer and a center punch. But while watching a video done by Kit Airplanes, they were doing this exact same exercise. And the guy popped one of these guys out, and basically you push it down, and when it goes click, it does a punch. Pretty impressive. I had no idea these things existed. So went on to Amazon and bought one, and so this is really the first time using one. So we'll see how it works. So get it in, and voila. So there is the trick here is to make sure to get it in the right location. As shiny as everything is. So as I'm looking at the center punch hole, I noticed that it's definitely dimpling the aluminum skin pretty good. So I'm going to go ahead and adjust the punch a little bit to have a little less force and see if that's going to make a difference or not. Because I don't necessarily want to divot or dimple the aluminum. That's just a couple. Yeah, but still pretty gung-ho. So we'll reduce it even more. That one looks a little bit better, so I think I'm going to back it out one more turn here. This is fairly lightweight aluminum. Smidge more. That one definitely looks better though. It's not as craterish as the other ones. I think I'm going to again back it up a little bit more. This is really a good learning opportunity for sure. That looks a lot better. Okay, so tell a little bit of a difference, that's for sure. The initial one's striking towards the back. Still looks like it might still be a little on the gung-ho side. So, okay, so we need to drill number 40 holes on one side and number 30 holes on the other. So I will get the drill set up and we'll start working on that. We now have the drill set up. We're using a pneumatic drill. After doing some research, it seems that when you're drilling aluminum, it's actually better to use a much higher RPM drill than what the battery operated one. So this drill pretty much cooks at 4,000 RPMs. So we will go ahead and okay, one set done. Now for the next set, and the next set we're drilling with the number 30. So we'll check that up, clean this mess off, and we'll be right back. Okay, so we got the number 30 checked up. Move this out of the way. And drill the holes on the other side. So on second thoughts, I just chucked up the number 30 to drill the initial holes, but I seem to remember reading somewhere that maybe you should do a number 40 first and then go with a bigger drill bit. So I think I'm going to unchuck this and go ahead and get a number 40 put on and then drill all these holes, then come back and re-drill them again with the number 30. So, and interesting enough, the question becomes, when I match drill this, will I be match drilling a number 40 or number 30? I'm thinking I'm just gonna match drill first with a number 40, then come back later and go ahead and drill the rest of it. So anyhow, I guess I got a little bit ahead of myself. So let me recheck this and we'll drill some holes. A couple holes more to go. Okay, that's that done. So I'm seriously thinking about doing the match drill on the angle iron first and then coming back and making all the holes bigger with a number 30. So the next step will be to grab some clecos, clamp it. I think I'm going to most likely start drilling the center hole first, and then we'll get the edges, and then we'll do the ones in between. So let me get that going and we'll be right back. And basically I'm just going to grab these cool little cleco clamps and we're going to use that to hold these pieces together. So matches also. So I'm going to grab one of these clamps. Clamp that there temporarily. Another one of the clamps in the pliers. Make sure that's nice and good on there. Okay. So that looks like it's all lining up good. Yep, I like it. So my first step here is going to be to drill a hole in the middle. So that way we can then put a cleco in here, take one of these guys, drill another hole, put a cleco in there, then we can take this one off and go that route. So the next step is that we'll just put a hole here in the middle. So this actually goes this way. So I'm going to mark this let's have a look. I'm just going to draw a little picture of angle iron on this side, so we know that's the way it goes. So I have the two plates together here. The instructions are not super clear. They just say it's 5/16 to the center of the rivet hole. I'm assuming it's 5/16 to the other side also. There's an overall dimension here at the bottom of, where is this? Right here, 3 7/8. So yeah, so we'll strike the line. We'll measure it. Again, this is a kind of a test anyway, so it's nothing critical. And we'll kind of go ahead and get these clamped together and do some match drilling, and then continue on. So let's figure it out real quick. So if we assume this is 10/16, we'll just kind of be lazy here. So 10/16 is 5/8, which is right there. So we'll do 5/8 over here. And in theory, if I line these 2 points up, we're going to get some number close to 3 7/8. And that's kind of what we're seeing here, 3 7/8. So yes, that's correct. So we'll go that route. We'll make the line, and then we will go ahead and clamp these together, and we will go from there. Once again, measure once. That's good. Strike the line. Okay, so I think that's all the number 40 holes drilled. Now it's time to have some fun re-drilling these 40s. We'll call this R. And we'll have some fun re-drilling all these to number 30. So, good times. And that's done. Now it's just a question of deburring all these holes, and also the edge of these plates, and we will cleco them together, and then we'll start putting some rivets in and moving on to the next phase of operation. So for deburring, I got this kind of cool little deburring tool that has kind of a sharp edge right here that you basically grab your piece of aluminum and you kind of work your way. And you can see it's getting some little shavings off. Take them off. And kind of cleans the edges up for you. So for our next fun step, we are going to deburr all these holes that we drilled. And we're going to do, that was a couple of things. So the holes that are number 30. I bought a cordless screwdriver from Home Depot, Ryobi. Wasn't too bad. This thing was on sale for 25 bucks. Nice thing about it, it moves very slowly, so gives less chance of using this as a countersinker. And this deburring bit for this was from Cleveland Aircraft, which was very expensive. It was $35 for it. I guess aircraft tools are as expensive as aircraft parts. But as I said, unfortunately, this will not work on the number 40 holes. On the number 40, I just have a drill bit that I just kind of go through and put in the hole, give it a firm twirl, and that pretty much takes care of it. The big thing is to make sure that you don't countersink these. So it's basically just enough pressure to get all the burrs off. That part is done. Now we'll do this part, and then we'll start looking at deburring the number 30 holes. So for our next trick, we're going to try the number 30 holes with the deburring tool. See how it works. Yeah, very nice. And then we will deburr the bottom of this. This top we're not going to deburr because we're going to countersink it anyway. So it looks like all we really need to do is deburr these holes in here. Yeah, very nice. Okay, so that's deburred. These are deburred. So we are ready now to figure out how the countersinking tool works. So that's the first time for me. So we'll go grab the bits and pieces and see how it works. Prior to countersinking the aluminum angle iron, we have to dimple the skids. In order to get the correct countersink depth, we have to be able to have the dimples already on here. And then you set it the depth by making sure that when the dimple fits in the countersink, the aluminum is laying nice and flat up against the angle iron. So first order of business will be go ahead and once we get all these done, then once that's done, we'll get back and go ahead and countersink these guys. In the meantime, I believe I'm going to start with the 40s since they're kind of close back. These are 3/32. So we'll get the 3/32 bits and pieces. Put it on the machine. The machine is not, the squeezer is not plugged into the air. That way there's no chance of me accidentally jamming my fingers in there, which I hear is a very bad thing. That would be what we like to say as no bueno. Can we get that in there yet? Nope. So looks like we just got to adjust it down first. The squeezer has this rod here is adjustable, so we can do what we need to do. So it looks like it's got to adjust all the way down here to get all the bits and pieces in. Here we go. Okay. So what we need to do here real quick is let's get the screw down a little bit. See how far when this thing throws all the way. What are we dealing with? Make sure it will go. Okay, so we go up. Okay, so we got a little bit of a gap. So while it's all the way out, I'm just going to adjust this to kind of take that gap off, tight, and then back it up a turn or so. So this is for the 3/32, which are the small holes. So we'll give one a quick whirl. See, how did that work? So what I'm going to do is I'm going to grab a rivet and stick it in there and see if it's deep enough. So just in case I need to adjust this a little bit more. So let me get that real quick and I'll be right back. So I have my handy dandy bag, which I went ahead and labeled earlier, so it's easy to figure out what size rivets these are. It's very surprising still though how small these rivets really are. They are teeny tiny by my standards. So, and that is looks flush to me. So yeah, I think that's going to work. So we'll get through and dimple the rest. The dimpler is definitely a heavy piece of equipment to be holding on to for a long period of time. Okay. So in theory, then this will fit nice and flat in here. And then we'll see these two go together. So it looks like they went together pretty good. So we can we'll get ready to cleco this. We can put some clecos in, and then we can rivet it. And it's a nice and flush. So yeah, that works great. Okay, so we will swap out and get the larger die for the 1/8 inch rivets, which are going to be across the front here. There's also a couple of pup rivets that will go in these two holes, so I kind of marked them both on here and here, so I don't countersink those by mistake. So okay, well, let's get this set up and we'll start the fun part of dimpling the larger holes. So let me get it set up and we'll be right back. So I decided I'm going to use the flush rivets over here in this position, and then we'll use the round-headed rivets on this other position. The plans actually showed it on the outboard side. Again, this is an exercise, so lessons learned. But for this particular project, I'm just going to worry about these two and just flip them around. So so my next job really then is to get the countersinker sorted out so we can get this in. So I did a quick tutorial online with Cleveland Tools to figure out how this countersinker works. So now that I've figured out, I've got it mounted to the drill. That way it's got the shaft lock, so we can basically tighten up the bit. Since these are number 30 holes, actually this is for 1/8 inch rivets. So we'll take the protective plastic coating off of here, in theory. There it goes. Okay, then this basically screws into the shaft. Now, one thing I can do just to save my fingers is stick this in here temporarily, and then I can just basically use the drill to tighten it up so I don't have to kind of sacrifice my fingers. Give it a good tightening. So, and then I guess the next step is figure out how deep this is going to go. So obviously, as you can see this right now, it's going to go way the heck deep. So we don't really need it that deep. So the way this is adjusted is this pulls back. And I guess every one of these teeth is 1,000. So we're just basically going to spin it until we lose some of that. So we would want to start, as always, a little on the conservative side. So we'll see how that looks. That actually looks a little deep at this point in time. So I'm gonna go ahead and adjust it back some more. The whole idea is you can always go a little deeper after the fact. So I actually bought 2 of these. That way, once I get, I think the number 30 and the number 40 are going to be the most popular. That way, once I get one set up, I don't have to continuously try to adjust it. So we'll hook this up real quick. We'll see how deep it countersinks. And so we'll give it a quick whirl. So We'll be curious to see how this one turns out. Definitely it's got some decent play, so I'm going to try adjusting it a little bit. I'm going to go a few notches. And I think also got to make sure this thing is actually level. Didn't do a very nice job. So I need to find out what the situation is, because it looked a little off round here. So we'll give it another whirl here. Again, thank goodness I'm doing this on the test and not on the actual airplane itself. So that looks like it might have been too much. If you like this video, hit subscribe and give us a big like down below. Thanks for watching.